They were literally doing that almost the whole varsity game.
Alright guys,
Yeah.
so, any questions from this? Which one's 17?
Yo, who got a job?
Other questions, guys? Anyone else?
I had the right word.
The first time.
The first time we went.
No,
look. Talk to me nice.
49.
Yeah, talk to me nice.
That's because we helped you a little bit.
Yeah.
No,
you would have kept
you
you would
would've
have
kept
kept 8,000 as your answer.
Probably.
How can you get 8,000? This doesn't seem right. Yeah, you're
Yeah.
off
Yeah.
8,000. Oh.
Alright, so we'll go through number 17. So one of the formulas that I forgot to tell you guys to put on your flow chart yesterday was mid-segment. So that might be one you might want to end up adding to your yellow sheet just as a kind of a thing to study. The mid-segment is when you take the two bases and you add them together and divide by 2. So it's a mid-segment of a trapezoid. So remember, it takes a trapezoid and it kind of slices it in half. It's basically the average of the two bases. So you needed that formula for number 17, which might have been why 17 was tough. But so it says in our trapezoid, they tell us the parallel pieces and then give us a few measurements. So let me draw this. They tell me WX is parallel to YZ. So they give us this trapezoid. So we know it's a trapezoid, which means we have the one set of parallel lines, which is why I drew it that way. They tell us these are the two parallel sides. And then they tell me YZ is 4.25 centimeters. YZ 4.25. And then they tell me the mid-segment is 2.75. So the mid-segment is using this idea. If I go through the center, that's 2.75. They want me to find the other base. So they want me to find this here. Call that for the, well, I should call it B, sorry. I was thinking mid-segment, but that's not the mid-segment. So we have to find the other base. So they give us the mid-segment, so they give us that value. So 2.75 is our mid-segment. And we have to take the bases and add them together and divide it by 2. And we did this before break, but I know it's been a while, so I don't expect that everyone remembers that, and especially since I didn't remind you guys of that formula. So in order to solve this, we like to get rid of that 2, so we're going to multiply each side by 2. So we do 2 times 0.75, so is it 5.5? I believe. I think so. And so then to get the the base alone, we would subtract this. So I believe we should get 1.25 if I do the multiplication correct back up there. Any other questions from the homework? So we are doing a new section of notes today, but at the same time, it really is kind of a review section. It kind of like trying to make sure you know all the different properties and kind of know what shapes they're talking about. So it's kind of a good lesson for this week, just that we come back from break and have to do a test. So we'll do that section today. We'll review tomorrow, and then again, we're testing on Thursday in here. So that'll be our last test before getting ready for our exam, but that gives us 2 days next week to get ready for exams. So tomorrow I'll get you guys that exam schedule, which is for next week. So just a reminder about that. Again, stay on top of homework, but at the same time, if you're unhappy with your grade right now and you still have like retakes to do, that might not be a bad thing to look into doing before the end of the semester here. So let me get you guys the notes. My puppy chewed my favorite mask this morning. I think she's protested me being back at work, so.
Okay. No. Okay. Somebody brought up
Okay, there's like 3 warm-up questions there.
What? Alright guys, so the warm-up question is a review of some of our different shapes here. One of the things is, first of all, try to figure out what kind of shape it is to begin with, so that gives you kind of a better idea of what you're dealing with in terms of finding those missing angles. So take a minute to see, if you can't figure out the first one, skip on to the next one. I'll give you guys a little bit of time here to try these. See if you can find the value of x for all of them. So there are 3 separate problems there.
Yeah, nope, that's good. Yeah, no, that's fine. I didn't know it. Yeah. Right, right. All right, are we good, or do we need more time? Okay. So, in this first one here, what kind of shape is this one? It's a trapezoid. Is it a specific type of trapezoid? It is isosceles because of those two marks. So I didn't ask you to do this, but knowing that is helpful, so we know kind of what we're dealing with. Because obviously, depending on the shape, there's going to be different rules. So in an isosceles trapezoid, the fact that I know those two lines are marked equal, and then, so then that means the base angles are also equal. So this and this are going to be equal. But that's not what they're asking us for. We want to figure out this angle, but it's the same as this one. So there's a couple of different ways you could do this. You could use the fact that you know they add up to 360 total, and then we have some equal angles here. But what do we know about these two? They equal 180. Those are supplementary angles because of those parallel lines. So x and 115 should equal 180. And obviously you probably don't need this much work, a lot of you. And then you move that 115 over. And we get 65. So 65 degrees for x. Now again, you could have realized that this would also be x, and then again the four of them together should add up to 180, or sorry, 360 because it's a quadrilateral. So either way you go about it works. And then being like, I heard these guys talking about it before, like making sure your answer is reasonable. So, I mean, obviously drawings can be like not to scale, but you know, kind of making some like conclusions about the fact of like what type of angle it should be. What's our next shape? What shape is this one? The kite. So, the kite. Now, the reason we know it's a kite is because of the consecutive congruent sides. So these two are equal, those two are equal. Now, in a kite, one of the big things has to do with the angles. So they give us that this one's 90. What do I know about the other two? They're equal. In a kite, there's always one set of equal angles, and so those two angles have to be the same. Now this time, I would suggest working through it the way we know it adds up to 360. I know last time we did this, I think some of you guys were trying to cut the kite in half and kind of do the 180, but I think it's a little bit easier to say that all of these together equal 360. So x plus 90 plus x plus 30 should equal 360. All the angles together add up to 360. So x and x is 2x. 90 and 30 is 120. What? I'm writing the same thing again. Move that 120 over. So I get 240. And then I divide by 2 and I find out, what do I get, 120 for each of those? All right, what's our last shape over here? It is a parallelogram, but there is a more specific name we can use. Parallelogram will get you the right answer in this case, but yeah, we also know it's a rhombus because of all the equal sides. So the more specific name would be rhombus. Now technically parallelogram's not wrong, just like, you know, if I called you a freshman and you're really a sophomore, like obviously that would be wrong, but if I called you a student at Random Lake, like it's general, but it's not specific. So rhombus is correct, is the most correct answer. Parallelogram's okay. So, but actually now that I say it, I think we need to know it's a rhombus in order to figure out the value of x. What do you guys know about, like, what did you use here? There's a few different things we can do. There's a few different things we need to do. Any thoughts? Anytime I see a shape like this, I always see those alternate interior angles. So like, I know that this and this are the same, so that's going to be x. But that's not going to be enough information. What else do you guys think here? Ellen, can you put your phone away, please? Thanks. What else do we know about a rhombus? There's a big thing that we need to know here. Do you know, you have the right answer, do you know why? How do you know that? Yeah, those intersect, those little middle lines here, intersect at 90 degrees. So we have here is a right triangle, where this is 90, this is 20, and then there's our x. So we're able to find that x value based off the fact that I know angles of a triangle add up to 180. So that's how we know that x has to be 70 then, because 20 plus 90 plus x equals 180. So we find out x is 70. Did anyone figure it out another way? I don't know. Yeah.
Because all the sides are the same,
Mhm.
I knew that all of the numbers, you can take 20 degrees and put it on the other side, it's the same thing.
Yeah.
So then I just multiplied 20 by 4 because of the 4 sides, and then I knew that it was 360, so I took 360 minus 80, and then divided that by 4.
Yeah, so essentially this is what he did he did a lot of it like kind of putting things together in his head, which is perfectly fine. But we can also know that a rhombus, because it bisects that angle, so all of those are the same. So 20 and 20, 20 and 20, so he was saying that was 80 altogether. And then there's 4 x's, that's why he chose to divide it by 4. And his thinking, like, it makes sense. It was what he noticed first, and I like don't want to fault you guys for thinking a different way and making it work. So I just wanted to make sure that you realize there are other ways, so it's not necessarily, I mean, obviously you have to know facts about a rhombus in order to solve that, but sometimes it's not the way that maybe I was planning on you guys getting there, but it still works. So he would have got 70 as well. Very good, thank you. I wondered if anyone else noticed that. So, so we're going to talk about quadrilaterals today. We're going to do a little bit review with like the angle measures because I think the angle measures of polygons are kind of one of the tougher things that comes up in this chapter. So I'm going to review that a little bit with you guys today. And then, like I said, tomorrow we'll review, and then Thursday we'll test on this chapter. And that's essentially it. So this is our last kind of new section, but hopefully it'll be a lot of review today. So it tells us we have a quadrilateral as one pair of opposite congruent angles. What types of quadrilaterals, so including all types, meet this condition? So see if you guys can make a list of how many different types that would work for. I would suggest trying to do it without your chart, but if you want to go back to that if you have absolutely no idea, but I'd say without is probably better right now to see if you guys kind of quizzing yourself and see what you guys know. I'll give you guys a minute. So how many different shapes have at least one pair of opposite congruent angles? At least one, so that means one or more. And if it helps to draw a picture, that's not a bad idea if you need to like kind of visualize. We want to make sure we get them all, that we find all of them. Opposite congruent angles. Now, opposite does mean like diagonal, just to make sure you're aware of that, so completely across from the shape from it. All right, someone give me one. I heard square. So square has those opposite right angles, so yes, that works. Actually, it's two of them. I heard kite. So kite's the one that at least one pair, so it has one that works, so kite only has that one set of equal angles, but that does work. What else? Rhombus. Okay. Sorry, my rhombus looks a little like another shape. Rectangle. And then, what else? Hey.
That room's so hot compared to.
I know, it's the craziest thing. I walk in there and like, you can see like,
I was like sweating.
yeah. Yeah, if you're ever cold, Mr. Hatfield's room is always like 10 degrees warmer than mine. He steals all my heat. I figure out his way out. Yeah,
Maybe Sosthenes trapezoid.
actually, so good point. I wonder if anyone would think that. Isosceles trapezoid, the base angles are equal, but then that means when they're talking about opposite, they mean like across. So, because this would be consecutive or adjacent. So isosceles trapezoid does not work. Yep. Parallelogram does though. So regular trapezoid doesn't work, isosceles doesn't work, and then obviously quadrilateral itself, not necessarily. So those are a lot of the shapes. So the next one, kind of asks the same question, but it says at least one pair of opposite sides are congruent. So again, similar question, and maybe my drawings help that, or take a minute to see if you guys can figure that out. Oh, sorry. Keep stuff for you. No. It's probably almost easier to make a list of what doesn't work. But- All right, guys, what do you think? Give me one. Opposite sides congruent. Give me one.
Square.
Square. All right. Rectangle. Okay, someone other than Michael. Go ahead.
Isosceles trapezoid.
There we go, our isosceles trapezoid. This one does work. So isosceles trapezoid does work. Because this one one does have those opposite legs that are equal. The one, at least one pair that works. What other ones, guys? Rhombus. Other one. Parallelogram. And we put kite up there. Does kite work? No, so they're not opposite sides. They're those consecutive sides. So kite does not work. Obviously quadrilateral, not specific enough. So you can flip the page over. So here they want the most specific name for the quadrilateral. So as specific as we can get. Again, so this is like being that I'm naming you by your first name, your middle name, you know, so like I'm not just calling out Michael's name. I'm saying specifically Michael Upson, you know, and making sure I specify. So we're trying to specify here. So tell me the most specific name you can use. If it helps to write other names, it could be, then you get more and more specific. So take a few minutes here, guys. Yeah. I assume that your camera didn't get fixed. So I wonder if they can give you like a loaner. He's not very good. So yeah, I was thinking you could use a loaner like to do your paint. Yeah, like I mean, other than stuff you save on your desktop, it all should be, you know.
What? They're watching each other that way.
You're allowed to go back.
Yeah.
Where?
Yeah, my 24-hour.
What is it?
It's, they have one every day at 8 times.
All right, guys. So, most specific name for the quadrilateral. So number 2, what would we call that quadrilateral? It's kind of a weird looking one. Most specific name. Yeah, what do you think? You put rhombus.
Kite.
Well, you disagree and say kite. So rhombus, kite, it kind of looks like both because we're used to seeing a rhombus look like that.
Oh, freaking way, that's a kite.
No, yes, there is.
Why is it not a rhombus and it is a kite? Then explain.
Because the consecutive sides.
Yeah, this is just a really weird looking
That's
kite.
a kite?
I know. Mind blown, I know. So the reason it's not a rhombus, so the reason it's not a rhombus, it looks really a lot like a rhombus. But remember, rhombus has to have all equal sides, first of all. And they're really close, but not all equal. But then, like a parallelogram has to have opposite sides are equal. So since we have the two sides that are next to each other are equal, and then these two are equal, it's just a really like fat kite. Like it's a kind of a weird looking one. So sometimes you think you're used to seeing it a certain way. Usually we draw this kite long and skinny. Very good. Gold star for Michael. Anyone else need a gold star as well? He obviously needs his.
No way. There was no way.
All right. How about the next one, number 3? What do you think? Yeah, trapezoid. Do you guys agree with him?
Yes.
So there's one set of parallel sides. So the one set of parallel sides tells us a trapezoid. We have to kind of check, is an isosceles trapezoid? Do we know?
No, it's not.
No, it's
How,
not.
how would it have to be an isosceles?
It needs two angle sides that are equal.
So we need to know that these are equal. But an isosceles trapezoid, what do we know about its diagonals?
They're
They're
parallel.
equal. The diagonals are equal.
They're equal.
So if I added those together, 75 and 62 is not equal to 64 and 80. So you're right, I was kind of devil's advocate there for a second. So this is just a regular trapezoid. Isosceles has equal diagonals. It has also other marks typically, but so specifically a trapezoid. All right, number 4. This is a stumper.
At first I put rectangle, but I don't think that's what it is.
Okay, it's a rectangle. What do you think?
Rectangle.
You think rectangle?
I don't think so. It doesn't have the equal things on the sides.
So we have one set of equal sides. So one set of equal sides obviously is half a rectangle. We
It's
need
nice
to
and
know,
small.
we have just like that 9 there, but I don't know what this one is. This one could be 8, it could be 15 for all we know. We have the one like diagonal being bisected, but we don't know for sure that the other
Is it a
one.
rhombus?
No gold salt.
Anyone know what we would call it? What would be the most specific name?
Parallelogram.
I don't know if anyone has it.
Star at this point.
Does anyone think they have it? I don't know.
Kite. Me and that worked for mine the last time.
I'm trying to see.
I was actually right
I don't know if I've seen the right answer yet. Anyone think they have it?
Triangle.
I think I've stumped you. Oh, we got it here. It's just a quadrilateral. It's not a specific shape, so that's kind of a tricky one. That's cheating. He may have changed his answer at some
He's not having
point.
his,
I thought it was rectangle though.
Okay, no, I appreciate the honesty. So yeah, it's sometimes we want to be so specific. We want to name it. I love you just kept crossing it out, but can't be it. So yeah, it's sometimes like we want it to be something because we think it has to be, but just be aware that not everything has to have a specific name. It can just be this general quadrilateral that we don't know enough information about. So kind of searching for that is also helpful and kind of being aware of that. So, like I said, what I wanted to do with you guys is do a little bit of practice with some of the angle measure stuff because I think that was early in the chapter and I think that was tough. So we can do that. Why don't we take a break though before we do that? Why don't we do would you rather?